Hey everyone, thanks for joining me as we dive into the world of compliance in machine learning. I'm really excited to unpack this topic because let's face it, while compliance might not sound like the most thrilling subject at first, it's absolutely crucial if you want your ML projects to succeed in the real world, right? So today we are going to explore the big players in regulatory space: GDPR, HIPAA, CCPA, and I promise to make this practical and actionable. Okay. Look, I've spent years navigating these waters with clients across different industries and have seen firsthand how compliance done right can actually become a competitive advantage rather than just a box ticking exercise. So, by the end of our session, you'll have a solid understanding of not just what these regulations require, but practical strategies for implementing them in your ML workflows. So grab your coffee and let's get started on this compliance journey together. Okay. So why compliance matter? Okay. So why should we care about compliance in machine learning? It's a fair question, right? Think about it this way: data is the lifeblood of everything we do in ML. We collect it, transform it, feed it to our models, and use it to make predictions that impact real people's lives. But here's the thing: that data often contains sensitive information about individuals who have placed their trust in us. So let me share a quick story. A few years back, I worked with a healthcare startup that was building a diagnostic tool. They were so focused on improving their model accuracy that they didn't pay enough attention to how they were handling patient data. Long story short, they faced a significant fine and, worse than that, a massive hit to their reputation and took years to rebuild. So the final penalties for non-compliance can be eye-watering. Okay. Under GDPR, companies can be fined up to 4% of their global annual revenue, or 20 million euros, whichever is higher. That's not a small change, okay? But beyond avoiding fines, there's something even more important at stake here, and that is trust. In an era where data breaches make headlines almost weekly, uh, demonstrating that you can take data protection seriously helps build, long-term trust with your users and partners. And here's something that doesn't get talked about enough, okay? Compliance actually forces us to be better at machine learning, as better machine learning practitioners. When we have to think about data minimization, we end up with cleaner data sets. When we focus on explainability, we build models that humans can actually understand and trust. These aren't just regulatory hoops to jump through. They're principles of responsible AI development, and that make our products better. All right. So what are the key regulations, right? So let's take a closer look at the major regulations affecting machine learning today. I like to think of these as the big three, though there are certainly others depending on your industry and region, right? First up is GDPR, the General Data Protection Regulation. It was launched in 2018, and it's probably the most comprehensive privacy law we have seen to date. Its reach extends far beyond the EU boundaries. So if you have European users, GDPR applies to you regardless of where your company is based. Okay. What makes GDPR special for ML practitioners? All right, a few things. First, there's the right to be forgotten. Users can request that you delete their data. Now imagine that means for a model that's been trained on thousands of users' data, right? How do you untrain a model? It's a fascinating technical challenge. Yeah. GDPR also emphasizes data minimization, right? So only collect what you absolutely need. This runs counter to the collect everything and figure it out later approach that's been common in big data, right? And there is a requirement for explicit user consent. So those cookie pop-ups you see everywhere, that's GDPR in action. Okay. So moving to HIPAA, the Health Insurance Portability and Accountability Act. If you're working with the health data in the US, HIPAA is your constant companion. It's all about protecting personal health information, or PHI. What's interesting about HIPAA in the ML context is that it was created well before machine learning actually became mainstream in healthcare, right? So we are constantly interpreting how its principles apply to new technologies. Uh, you know, at its core, HIPAA requires the strict encryption of health data, careful control of who can access that data, and detailed audit trails of all data access. Last but not the least, we have CCPA, the California Consumer Privacy Act. Think of it as America's answer to GDPR, though with some important differences. It gives California residents the right to know what personal data is being collected, the right to delete personal data, and the right to opt out of the sale of their personal information. Right. So, and what's fascinating about CCPA is that it started a domino effect, right? Virginia, Colorado, and several other states have followed with their own privacy laws. So even if you're not operating in California, similar requirements are likely coming to your region soon. So remember, these three aren't the whole story, okay? Depending on your industry, you might also need to comply with regulations like FERPA for education or FCRA for credit reporting or other sector specific rules in banking and finance, right? All right, so GDPR compliance and machine learning, right? Now let's dive deeper into GDPR and its specific impact on machine learning workflows. So, one of the trickiest aspects of GDPR for ML teams is the concept of data processing agreements, or DPA. Basically, you need to clearly document and explain how you're using personal data. But here's the challenge: ML processes can be complex and iterative. Your data scientists might experiment with different features, model architectures, and training approaches. Documenting all of this in a way that's understandable to non-technical stakeholders can be really challenging, but extremely important, right? Then there is the matter of data subject rights. So if a user requests access to their data or asks for it to be deleted, you need processes in place to handle those requests promptly, right? This becomes particularly complex with ML systems, right, where user data might be embedded in model weights or used to generate synthetic data. Let me give you a real world example. Uh, a friend of mine works with a retail company that uses ML to personalize shopping recommendations, right? When they received their first deletion request under GDPR, they realized they had no system in place to identify and remove a specific user's data from their training sets and models, right? So it took them months to develop a proper solution, during which they were technically out of compliance, right? And algorithmic transparency is another GDPR requirement that directly impacts ML. So users have the right to understand how automated decisions about them are made. This is pushing the field toward more explainable AI techniques. Tools like SHAP, right, Shapely additive explanations, and LIME, that local interpretable model agnostic explanations, are becoming essential in the machine learning toolkit, not just for scientific insight, but for regulatory compliance. One approach that's gaining traction is using synthetic or anonymized data for training. So by generating artificial data that maintains the statistical properties of real user data without containing actual personal information, you can reduce your GDPR exposure significantly. But be careful. Anonymization must be robust, right? Simple techniques like removing names or IDs often aren't sufficient to truly anonymize data, especially in high dimensional spaces, right? Okay, moving on to HIPAA, right? So when it comes to healthcare and machine learning, HIPAA is the regulation you will deal with most in the US context, right? So let's talk about what this means practically. Protected health information, or PHI, includes a surprisingly broad range of data. Obviously, right? Medical records and lab results count as PHI, but so do billing records for healthcare services, appointment schedules, and even the mere fact that someone is a patient at a particular clinic. So even if you remove obvious identifiers like names and addresses, data can still be considered PHI if there is a reasonable basis to believe it could be used to identify an individual, right? So if you're building ML models in healthcare, you need to be using infrastructure and services that are HIPAA eligible. So if you're AWS, that includes SageMaker for building and deploying models and KMS for encryption. But not all AWS services are HIPAA eligible, right? So you need to carefully check before incorporating any new service into your ML pipeline. Role-based access control is absolutely crucial, right? Your data scientists need access to develop models, but that doesn't mean they need access to all the patient data all the time. Implementing the principle of least privilege, giving people access only to what they absolutely need, is a key part of HIPAA compliance. All right, let me share a quick tip from experience, right? Document everything. If you are ever audited, having your clear documentation of who had access to what, when, and why can save you enormous headaches, right? The encryption requirements under HIPAA are also strict. Data needs to be encrypted both at rest, when it is stored, and in transit when it's being moved between systems, right? So this applies to your training data, your model parameters, and any PHI used to make predictions. But despite these challenges, healthcare is seeing some amazing ML applications. Disease prediction models are helping identify patients at risk for conditions like diabetes or heart disease before symptoms appear. Right? Medical image processing is revolutionizing radiology with models that can detect potential cancers in a scan with remarkable accuracy. Right? And the compliance hurdles are worth overcoming because the potential benefit to patients is significant. All right, so let's talk about CCPA, right? While GDPR and HIPAA have been around for a while, CCPA represents a newer wave of privacy regulation. And it's worth understanding where things are heading, right? So CCPA gives California residents the right to opt out of having their data sold. This might not seem directly relevant to ML at first, but consider this. If your business model involves using customer data to train models, and those models are then sold as a service, you're effectively selling your user data. It's a gray area that courts are still working on, so and I'm not a lawyer, so I can't tell you, but it's definitely a gray area. CCPA also mandates clear privacy policy, so you need to explicitly inform users about what data you're collecting and how it will be used. Again, this can be challenging for ML workflows, right, where the use of data might evolve as models are developed and refined. So, looking ahead, there are emerging regulations that will further shape how we develop and deploy ML systems. The EU's proposed AI Act categorizes AI systems based on risk levels, with higher risk applications facing stricter requirements. For instance, AI used in critical infrastructure or to evaluate creditworthiness would face intensive scrutiny, right? In the US, National Institute of Standards and Technology, NIST, has developed an AI risk management framework. While not legally binding like GDPR and HIPAA, it's likely to influence how US regulators approach AI governance. If you want to stay ahead of these emerging regulations, start conducting data protection impact assessment (DPIAs) for your ML systems. These structured assessments help identify and minimize data protection risks, right? And also maintain comprehensive audit logs for model decisions, especially for high impact applications like lending or hiring. Okay. All right, so moving on to some best practices for compliance in machine learning. All right, Now that we have covered the major regulations, let's talk practical strategies for maintaining compliance in your ML workloads, right? So, first and foremost, data minimization. I can't stress that enough. The less personal data you collect and process, the smaller your compliance burden will be. Before collecting any piece of data, ask yourself, do we really need this for our model to perform well? Often the answer is no, right? I've worked with a fintech company that was collecting over 200 features about each customer for their credit scoring model, right? When we actually analyzed feature importance, we found that just 30 features accounted for 95% of the model's predictive power. Just 30 features out of 200, okay? So by eliminating the unnecessary data collection, they reduce their compliance risk substantially. Anonymization and encryption are your best friends in the compliance world, okay? Techniques like differential privacy add noise to data in a mathematical way that preserves overall statistical properties while protecting individual privacy, right? So companies like Apple have been pioneers in using differential privacy to train models on user data without compromising privacy. For encryption, use industry standard approaches and try not to roll your own crypto. That's a recipe for disaster. Okay. So AWS KMS and similar services make it relatively straightforward to implement robust encryption. Explainability and bias audits are becoming essential. Okay. Essentially, especially for high stakes ML applications. Tools like Interpret ML, AF Fairness 360, and Equitas can help you understand not just how your model is making decisions, but whether those decisions might be unfairly impacted protected groups. Documents these document these analysis thoroughly, right? Uh, they will be invaluable if your model ever faces regulatory scrutiny. And I need to keep stressing document, right? And then continuous monitoring is something many organizations overlook. Okay, compliance isn't a one-time achievement; it's an ongoing process. Models can drift over time, leading to unexpected behaviors. Data sources can change. New regulations can emerge. So set up regular compliance reviews for your ML systems, just as you would for model performance reviews. Okay. And here is a practical tip. Designate a compliance officer or team for each ML project. This person should be responsible for staying current on relevant regulations and ensuring the project meets compliance requirements. Ideally, they should have both technical understanding and regulatory knowledge, or at least have access to experts in both domains. All right, so let's wrap this up. Okay. I want to emphasize that compliance isn't just a legal necessity, it's a business imperative in today's data driven world. GDPR, HIPAA, and CCPA each require specific approaches to handling data, right? But they share common principles: respect for users' privacy, transparency in data practices, and security in data storage and processing. So, by designing your ML systems with these principles in mind from the start, you'll save yourself countless headaches down the road. AWS provides a robust set of tools to help with compliance, right? From HIPAA eligible services to encryption capabilities and access controls. Take advantage of these. I mean, there's no need to reinvent the wheel when it comes to compliance infrastructure. Remember that building ethical AI and maintaining regulatory compliance go hand in hand. The same practices that keep you on the right side of the law, data minimization, explainability, bias prevention, also lead to more trustworthy and responsible AI systems. So I encourage you to view compliance not as a burden, but as an opportunity to differentiate yourself in the market. In a world where data breaches and AI ethics regularly make headlines, organizations that can demonstrate strong compliance practices build a stronger trust with their users and partners. I would love to hear your questions and experiences with ML compliance. Like, what challenges have you faced? What solutions have you worked for? Let's continue this conversation because, sharing knowledge is how we all get better at navigating this complex landscape, right? Thank you for your attention today, and best of the luck with your with rest of the journey in this course.